All right, folks, thanks for watching my video. We've got to convert a point like this in polar form to rectangular form. That's the first set of problems that we have. So let's review how to do that right now. Okay. I think yesterday we mentioned that, this point right over here would be, over some X amount, right? That's our X amount. And then it's up some Y amount. Okay. So when we look at it that way, we're trying to get the X and the Y component. That's the rectangular form. So when it says convert from polar form, it's going to be an R theta, like it's 5 away from the pole at 60 degrees, right? So let's look at what that looks like. 5 away in this direction. So that's our 60-degree angle right there, 60 degrees. And we're, like, I don't know if I'm going to do a very good job estimating this. 1, 2, 3, 4, 5. Okay, so let's say that's where our point ends up. It's 5 from the pole, and it's 60 at a 60-degree angle, right? But our goal is to get it in terms of X and Y. Well, we know 60-degree triangles, 30, 60, 90 triangles so well that you might not need trig to do this problem, right? You might say, well, the short leg is half of the hypotenuse, right? If this is 5 long, the short leg's 2.5, and the long leg is 2.5 times the square root of 3. It's square root of 3 times bigger to go from the short leg to the long leg. So you might be able to just go straight away and say, well, this is 2.5, comma, 2.5 square root of 3. And if they ask for an exact value, that's right on the money. But if they ask you to round it and you're not given a 60-degree angle, then they're asking you to do something like this. This part right down here is the adjacent leg to the 60-degree angle. So you could say the cosine of 60 is equal to X over 5. And then you can multiply both sides by 5. So I go, multiply this by 5, multiply the right or left side by 5, right? And the 5s here are going to divide out to 1. And so now we're down to X equals 5 times the cosine of 60, right? So this right here is the same thing. 5 times the cosine of 60 is the 2.5 number. And then by the same reasoning, this over here, the opposite leg over the hypotenuse, that's the sine of 60 degrees, is equal to Y over 5. And you multiply both sides by 5, you get 5 times the sine of 60. That's equal to your Y value. So we get 5 times the sine of 60. So let's think about a way to convert every single time from polar form to rectangular form. What you want to do is, the X component, the X, is going to equal R times the cosine of theta, and the Y component is going to be R times the sine. Oops, doggone it, that's not coming out so good. R times the sine of theta. All right, so that's how you're going to find your X and your Y if you're given an R and a theta. Okay, so I want you to pause the video and go try as many problems as you can right now until you've exhausted the ones that say convert from polar to rectangular, and then come back and we're going to try one going the other way. All right. All right. Thanks for pausing your video. Let's take a point, and since I've kind of cluttered up the first quadrant, let's take a point over in the second quadrant and let's make it in rectangular form. So let's say I went over 3, and I was going to say let's go up 4, but that would give us a hypotenuse of 5. Maybe that's a little confusing. I don't know. I'm going to do it anyways. So I'm going to go over 3 to the left, and I'm going to go up 4. So that point right up there, this is in rectangular format, is -3 comma 4, right? And our goal would be to convert from rectangular form down to polar form. Okay, so how do we do that? Well, first thing I need to do is, oh geez, that's not even going close to where I want it to go. Give me a second here. I want it to go right to that point right there, right to the origin. Okay, so boom. I need to know how long this is right here. Well, if this leg is 3 and this leg is 4, well, this is 5 right here. It's a 3, 4, 5 triangle. So I've cheated a little bit, right? So when I start getting this point in polar form and I say, hey, I'm going to go 5, right? How did I get that? Well, I'm using a Pythagorean triple, 3, 4, 5. So, right, you're going to go 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. C equals the square root of 25, which c comes out to be 5, right? So like you're going to do x squared plus y squared, right? And that's going to be equal to your hypotenuse squared. That's going to be equal to the radius squared. So to get the radius, you're going to want to take the square root of the x squared and the y squared. So we go x squared plus y squared. I'm showing you this because I want it to make sense. I don't want you to memorize something. I'm just going to blindly, take the x and square it and take the y and square it, add them together, take the square root. That's going to give me the r, right? Now, to get the angle, let's think about that for a second. To get the angle, we need to figure out, what angle is over here. Now, the tricky part about that is if I do the inverse tangent, let's try that. So like this is -3. We're coming back 3 and we're coming up 4. If I go inverse tangent, where am I going to put that? That's neat here. I'm going to put it right up here. Inverse tangent, or first I'm going to do this. Tangent of theta would be equal to negative, it'd actually be 4 over 3. What am I doing? It's going to be the y over the x, right? Let's see here. Why did I just put a negative up there? It's going to be the y over the x. That's what the tangent's equal to. So I go 4 over -3, right? So then I do the inverse tangent to get my theta by itself. So I go inverse tangent of the y is 4 and the x is 3, right? So 4 over -3. Okay. So let's go over to Desmos and let's see what that looks like when I go inverse tangent of 4 over -3. All right. So I'm getting my Desmos open. I've got one right here. And I go tangent inverse of 4 over 3. 4 divided by -3, excuse me. And that gives me -53 degrees. Negative 53.13 degrees. That's kind of weird. Like when I look over here, -53 degrees is down there, right? So like what I'm getting is this angle going this way is -53 degrees, right? That's negative. I'm going to just round it to the whole number. Well, doesn't that mean this angle right here would be 53 degrees, right? Because those two are vertical angles. So I want to stop 180 short of 53 degrees, right? So this process is going to take some thinking. There's no like, hey, just do this every time you're going to get the right answer. I think you need to make a drawing and you're going to have to think it through. So I'm going to go 180 minus 53, whatever my number is over here, right? So it'd probably be best to go 180 minus this to get as accurate as possible. So 180 minus that. So it's going to give me, oh, that was because that was a negative, sorry. So I'm going to make it plus. I know it's going to sound weird, but remember this was a negative number. So that's going to give us 180 minus the 53 number, right? Ooh, I don't really like the way that's coming out here. So let me go back here and I'm going to call this angle, I'm going to call it D. D equals, okay? Now, usually you use a capital letter for an angle, so I'll make it capital D, okay? So then you go 180, and you see that it's a negative number right there. So I'm going to add it to D just so I can get that subtraction going on. So I get 126.86. So that's what my angle needs to be, 128, whatever it was, 126.86 or 7. And make sure you round to the correct decimal place and all that kind of stuff, right? Because think about it, like if we were down here in the third quadrant, we went back 3 and let's say down 4, well, it would give us a 53 degree angle and we'd have to add that 53 to 180, right? So let's look at that. Like, let's say this was both negatives, right? That would make it a positive 53 degrees. That would put my point right down here in the fourth quadrant, right? So let me just get rid of this line right here and let's put a coordinate down there. Let's put it at -4, comma, oh, it was -3, comma, -4. -3, comma, -4, right? And let's label that point. That's my point right down there. But that's definitely not a 53 degree angle, right? So what angle am I at right there? Well, it'd be 180 plus that, or 233. So I'd be at a 233 degree angle to get down to that point, right? And it would be 5 away from the pole. So coming back, if we're trying to get some notes in here, the theta is going to be the inverse tangent of y over x, right? So let's put that right here. Theta is the inverse tangent of y divided by x. However, do some thinking, plus thinking. I'm going to call it that because you've got to put it into the drawing, and it's, inverse tangent is only going to give you an angle between -90 and +90, between negative pi halves and positive pi halves, because of that domain restriction, right? Because they want it to be a one-to-one function. And so you've got to place it into the second or the third quadrant if your point is not there. Okay. Whew, that's going to be a challenge. I know you guys are up for it. Thanks for watching my video, and thanks for doing the best you can.